I want you to skip it. Turn it over and skip it. You know, like you open up the brand new notebook, right? Oh, first of all, I guess you guys should put your name in there. Your name in there? What's your name in Walker? You got your name in there? Okay, so the very first page, I'm going to give you something to glue onto this first page a little later. So I need you to save the first page. You're going to start writing notes on the second page. This is stuff, this notebook right here.
Stuff you're going to need to carry with you like next year
in 8th grade. Percents are never going to go away. You're going to have percentage of a number next year too. So I wanted you to create some kind of a book that you can hold on to and take with you next year. So whenever you forget how to do percents, you have something to look back on. What could you predict is my word that comes after always? Percent is always what? 100. Good. That is definitely a rule. Percent is always 100. The percent symbol is made out of 100 to remind you that it's always 100. You can also hear those words being read out of 100. because that's what that means. Percent is always out of 100. Is it okay to move it there? It's not okay to move it there? When you are connecting fractions to percents, you can think money. Or you can do long division. For an example, thinking about money for the fractions of 1/5. One fifth plus 1/5 plus 1/5 plus 1/5 plus 1/5 equals 5/5 or 1/2. And we did this yesterday when we did dimes. If I take 10 dimes, which is $1, and I put them into 5 groups, how many dimes do I have in each group? 20 cents. So all of those dimes I just drew there equals one whole dollar. In one group, one of the 5 is 20 cents or 20% of $1. And if I add all those up, 20, 40, 60, 80, 100, I get my dollar back. And if I add my percentages, 20%, 40%, 60%, 80%, guess what? I get 100%. And I should. If I don't, something's wrong. So that's an example of thinking about money. Now I got to give you an example of long division. The 1/5 is fraction form. And I need to convert it to a decimal, so I need to do some long division. What goes on the outside of the box? The 5. And the 1 goes inside the box because it's 1 divided by 5. But I can't do that without doing what first? Decimal. And at least 1 0 for this one, because we all know what it is now. So I ask myself, how many sets of 5 can I take out of 10? 2 sets. Uses them all up, leaving 0 remainders. So the decimal form of the fraction 1/5 is 0.2. And then to get it into percent form, I move my decimal 2 places to the right and add the percent symbol. Once again, those 3 representations all occupy the same spot on the number line. I can write it in fraction form. It means the same thing as decimal form, and it means the same thing as percent form. They all hold the same spot. It's just different ways of writing. Let me know when I can turn my page. Miserable hiccups again. Are we ready? Looks like it. Okay. On this next page, and I'm mostly speaking to myself out loud. Draw straight lines as straight as you can. Yeah, that's not going to be possible for me. right across that top margin. And we're going to label it fractions, decimals, and percents. Zoom in on that. So going from fractions to decimals, you can do one of two things. You can either think long division to get there, or you can think about money and coins to get there. I'm going to make an arc from decimals to percents. Wow, that's a terrible arc. To get from a decimal to a percent, you're going to move the decimal 2 places to the right. That's what I tried to write up there, but I didn't write it so small that it would fit. Or essentially what you're doing is you are multiplying by 100. When you move that decimal 2 places to the right, that's what you're doing. To what? Which one? The long division one? This one? Yeah, I tried to cram, move 2 decimal places. It fell off the arc. Let me know when you got it. Got it? Okay. That's called a French bracket. Have you seen those before in language arts? French brackets? Okay. Well, if you can't make a French bracket, it's okay. You don't have to. Put some kind of a bracket that you can make right there. Because with this group right here, you can think quarters. Once again, that says think quarters. Quarters, quarters. Okay, for the decimal representation of a half, what does that look like? For the decimal representation of 1/4, what does that look like? Because that is 1/4 out of 4 to make $1. Remember, we're doing percents. Everything is 100. What's the representation in decimal form of a fraction 3/4? 0.75. So now I'm going to move the decimal 2 places to the right to put all of these decimals into percent. Please write as neat as possible. Remember, you're going to use this holder next year. The next section, I kind of want you to watch how I put it in there, because I'm going to like alternate the fractions because they need more room vertically to write them. For the fractions that have the denominator of 5, you are going to be thinking dimes. Think dimes. Think dimes. So for the top one, you're thinking quarters. And for this one, you're thinking dimes. How many dimes does it take to make $1? 10. That's what we're grouping. Okay. What is the decimal representation of 1/5? That would be the fraction 1/10 if it was 0.10. Ooh, maybe I need to go over some of that again. I'll do that. How many dimes? If you take 10 dimes and you put them in the groups of 5 because the denominator says 5, how many dimes you have in there? Turn your page back and look. I think we did that. You have 2 dimes in there. So how much is 2 dimes? 20. Now you can either put 0.2 or 0.20. I don't care. It says the same thing. 2/5. 3/5. 4/5. And 5/5. The whole thing. And so I always write it like that. Okay, take it to percent by moving it 2 places to the right, the decimal that is. Please be sure to check that you have everything written as nice and neat as possible. Once again, you're going to be using this book next year, just in case you forget something. Everybody got that? Okay, moving on to the next session. Again, I'm going to alternate the fractions. A dead bug. That was a dead gnat. One eighth, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and all of them. We're going to do these ones first that I have in this column because 2/8, 4/8, 6/8, and 8/8 remind you of other fractions. These are just not in simplified form. 2/8 was simplified down to what? 1/4. 4/8 simplifies to divide both by 4, babe. You get 1/2. This 6/8 is 3/4, and the 8/8, it's all of it. Let me zoom in real close so you can see. We already have the decimals for these, right? Okay. This time, writing the decimals, I'm going to stagger them as well. 1/4 of a dollar, 25 cents. 1/2 of a dollar, 50 cents. 3/4 of a dollar, 75 cents. And 8/8 is the whole thing. Now, we should know from the memory quiz, 1/8 was decimal 125, then 375, then 625, then 875. Oh, you see how my decimals are kind of staggered as well? This kind of helps you separate the ones that you should know from above versus the ones that are new and that you gotta know. Zoe, do you have a bracelet on? Is that what keeps sliding? Okay. Can we do something about that? Because I'm sure that this is a recorded lesson and it's getting picked up on the mic. I'm sure of it. Just for a little while, then. Okay, so over here in the percent column, I'm going to stagger that as well. To go to a percent, I just take the decimal, move it 2 places to the right, and leave it in there. Those are the only 4 decimal places that you're going to find in the percent thing that's going to be very familiar to you. The people who do like 6th and 7th grade, they love this fractions with 8s. They do. They love it. You're going to see that a lot. Does everybody have like maybe that much room in the bottom of that page? So in this bottom page, let me show you the long division. And instead of doing the algorithm like we traditionally do, I'm going to take this opportunity to show you box division. just do it this way. And this is just annexing some zeros. And how many do we normally annex? 3. Just to be on the safe side, whether we need them or not. Sometimes we don't. So this is taking a fraction and turning it into a decimal using the box division method instead of the traditional algorithm. How many sets of 8 can I take from the 1? So I put a 0 there. What's 0 times 8? So that's what I subtract out. I have a remainder of 1. I take the 1 and I pop it into the next box. How many sets of 8 can I take out of 10? Because I'm dealing with what's in this box right here. Just 1. 1 times 8 is? Leaving me a remainder of 2. What do I do with the 2? Move it to the next box. How many sets of 8 out of 20? That uses up 16. With the remainder of 4, I popped it into the next box. How many sets of 8 out of 40? Now they are all used up. Okay, go take your 4-minute break and come back and we'll finish this in a minute. Stop her down the door. Natalie, go ahead, turn your mic up and talk to me. Oh, okay. To answer your question, you have to do all the remediation work. And once you show me all the remediation work that I have listed in focus, then I will allow you to retest. It would be pointless to allow you to retest if you didn't do the remediation work. So it makes no sense. So yes, you can retest once you show me all the remediation work. I also answered that question when you typed it out and sent it to me in focus. So I don't know if you looked in there or not. Are you able to follow along okay with the notes? Okay, good. I'm going to go ahead and mute the mic because it's crazy out there in the hallway. Okay. So once again, this is long showing how it's turned and converted into a decimal by using the box method. If you don't have a whole lot of room for the long bit, you know how sometimes an algorithm just needs to put it real long. This as well. So then if you know what it is for one group of 8, to find 3 groups of 8, all you could do is just simply multiply by 3. And that will give you what 3/8 is. And then you put your decimal in. Say again, I'm sorry. Then if you need 5/8, what am I going to multiply one group by? By the 5. So you get the idea on how you do that. You just take the numerator pieces and you multiply it by what it is for one group of 8, and you can always get your answer. Hey, I'm ready to turn my page. Y'all ready to turn yours? The last set of fractions that you're going to see most commonly used are the thirds. Hold that thought. Now turn it. Hoffman. Mhm. Okay. That would probably be better if she just called him whenever it fits into her schedule instead of. Okay. Uh-huh. Bye. Hello. This is she. Can I help you? I'm teaching. Thank you. They call me today. We're going to do long division here to show how that repeat. I'm also going to use the box division. Just in case you forget, long division is dividing the numerator by the denominator. So how many sets of 3 can I take from 1? I can take 6 sets of 3 from 1. How many sets of 3 can I take from 1? 0 times 3 is 0. 1 subtract 0 leaves me a remainder of 1. What do I do with the 1? Now I've got 10. How many sets of 3 can I take out of 10? There's 3. 3 times 3 uses up 9. 10 minus 9 gives me a remainder of 1. Pop it into the next box. How many sets of 3 out of 10? 3 again. Uses up 9. Pop it into the next box. How many sets of 3 out of 10? Yes, that's my point. And so on. It's going to go forever. This will never change. This is what we call a repeating number. So what we do, we use repeater bars. That's why the repeater bar is up on top, because it goes on forever. And if you show the repeater bar up there, you're sharing that you know that is a repeating 3 forever. Has everybody got that so far? Put it in my, it's up there. And then if that's one group, 2 groups is going to do the same thing, but this time it's going to be 6s. And then 3 groups of 3, that would be all of it. When I move my decimal point 2 places to the right, I add my percent sign. The repeater bar drops off because I am rounding it, and everything else just falls off. When I do 2/3, though, it's not 66%, it is 67%. And here's a way you can check yourself to make sure that you have this correct. 33 plus 67 should always give you 100%. 7 and 3 is giving me that 10 with the carryover. The 6 becomes a 7, 8, 9, 10. There you go. Okay, so that is actually everything you need to know for the memory quiz, which you already have remembered. We've already tested on it. Turn to the next page. Did you not get it? Here. What do you need? Which one do you need? The top or the bottom? The what? You got it now? Let me know when you're ready. You ready right now? Yes, Natalie, these notes will be on Canvas. That's why I'm recording the lesson, so it's posted to Canvas. Sometimes you just might get a test question that says, hey, take this fraction and take it directly to a percent. There's an easy way of doing that. If you're taking it to a percent, you are always going to use 100 for your denominator. Why? And we're talking about percents. And what does percent mean? 100, always. So if I take 2/5, I need to get it to percent, but I have to do a couple of steps along the way. Now, my rule is I have to get my denominator to 100. It can't be a 5. It's got to be 100. So I've got to increase this through multiplication. 5 times what gets me to 100? 20. So if I do that to the denominator, what's 2 times 20? Now I've got 40 pieces out of 100. I take this 100 denominator, rewrite it as a symbol. Okay, take my numerator and pop it right in front of that symbol. 40 out of 100, 40%. That's what that means. Does that make sense to you? What did I say my denominator had to be? Always. I'm going to take 4/10 and make it into a percent. Okay. So I ask myself, if I'm going from 10 to 100, how do I increase that through multiplication? Times 10. If I do that to the bottom, 4 times 10, I take my 100, I convert it to a symbol because I am going to percent from a fraction. And then I take my numerator and I plop it right in front. Once again, I've got 40 out of 100, or as we commonly say, 40%. Make sense? Okay, let's try another one. Now I'm working with a denominator of 2. How do I increase that to 100? Times what? Times 50. I do it to the bottom. So now I've got 50 pieces out of 100. Take the 100, make the symbol out of it, and take the numerator, pop it in front. This says 50 out of 100, or 50% as we commonly know. Is this hard? Shouldn't be. Another denominator that you're going to see a lot is 20. But you never stop asking yourself that question. How do I get from 20 to 100 through multiplication? And if you're not sure, count by 20s, 20, 40, 60, 80, 100. So it's only just 5. So then I multiply that against my numerator to get 15. My 100 becomes my symbol now. My numerator becomes the number in front of my percentage. This says 15 out of 100, are commonly read as 15% as we know it. Are we still okay? What number do I multiply 25 by to get to 100? So then now I've got to multiply 18 by 4. See, 4 times 8 is 32. If I carry my baby 3 over there for my carryover, 4 times 1 is 4, 5, 6, 7. 72 out of 100. So it's 72%. As long as I have my denominator of 100, my numerator is my percentage. One last one with a denominator that you're going to see a lot. If you notice, I'm trying to change them to the ones that you're going to see. You'll see 5s. You'll see 10s. You'll see 2s, 20s, and 25s. What's the last one do you think you're going to see? 50. So we're going to do one with 50. And so how do I get from 50 to 100? And so that would be a 44, making it a 44%. Those are the common denominators that you're going to see throughout this whole module. And I wanted to make sure that you were set up for that. So the paper that you're going to practice doesn't have anything different. You've got 5s, you've got 20s, you've got 50s, 25s, 10s, and a 4. Did I do a 4? I didn't do a 4. What would you what would you multiply a 4 by to get to 100? 25. So you guys know that one? Okay. So you're going to take this. This is your homework, and you can do it now. You're going to take this piece of paper, and you're going to fold it to where I think it'll fit, right? Okay. And how you're going to glue this in is just by the top. On the other page. Let me show you. We'll zoom out. Just across the top. That's it. Because that way you can lift it up and work underneath if you need workspace underneath. Now, we're trying to keep this as neat as possible. Once again, you need to tote it with you next year. So I need it to be on the opposite side of the notes. So you have good examples. Okay, so you have the rest of this class period to complete this. Who knows where ISS is? Bradley, will you take this over there to Natalie?